Okay, sharing. Please confirm that I can be heard clearly. Where is my window? Come on.
I can hear you.
That's great. Okay, now is my desktop visible? Because I don't.
Oh, just you.
I don't. Strange, I don't see the window. I wanted to share the window in particular, but okay. I probably wouldn't be able to see some of. Oh no, chat is here. Okay. So it's so much to say and so little time for that. So let's a quote from famous movie. Okay, ramblers, let's go rambling. First of all, let me define the scope of this talk. Many misunderstandings come from unclear definition of terms, subjects, whatsoever. Of course, I'm not going to talk about procrastination. No way. And it doesn't work as I expected it. Okay, now it does. Instead, of course, I'm going to speak about lazy actions. And lazy actions are those which cannot take place until really requested, or they might be not done whatsoever if not requested. And actually, well, after all, I'm speaking about procrastination here. But more particular
Adam,
is the case.
We cannot see your screen.
You cannot see it. Okay. My apologies. Come on, we needed some kind of rehearsal. Stop, share. Can you see it now?
Yes, can see a screen now.
Okay, the presentation is visible, right?
Good now.
The scope and two bullet items, are they there?
Yes.
Okay, thank you very much. I'm sorry for that. Well, then you haven't seen the title page, I guess. Like this. Anyway, skip this one. Sorry for that technical issue, and back again on the track. I'm going to discuss lazy attributes, a particular case of laziness. A lazy attribute in my definition is the one which takes its value when the value is being read for the first time. Until then, it remains in undefined state, which is in a way reminds me about quantum physics. What's the purpose of laziness? Again, it's my view, you may not share it, but again, it's about better code quality, because laziness often allows to itemize initialization tasks, split it into smaller chunks, and when you have a smaller chunk, it's better manageable. For interactive applications, responsiveness could be improved because if you don't do extra job which is not currently necessary, it often means less waiting time for a user. And auto-resolve dependencies, this one needs a little bit more work, so it's going to be discussed a little bit later. Basic example where we normally start without laziness. Let's say we have an application which outputs something to in some kind of text information. It could output either to a file or to a console, and depending on where the standard output is attached to, it chooses between colorful or monochrome theme. So when we do instant initialization, what we have, say attributes need to be computed before they're set. Then that means we have our construction method tweak, and there we do the job. We check out if console attribute has been set already, because when we create an instance of our application class, we can pass console as a named argument and initialize it earlier. A user can do it. So we check out if it's been initialized already. If it doesn't, we check out if our output is a terminal. And depending on the value in console, we choose one theme or another. Now, it's just 2 attributes. Just imagine many of them. Some applications may have like tens of attributes, and many of them are to be calculated in one way or another. So you need to manage it somehow. And if there are complex dependencies between them, you have additional conditions and so on, so on, so on. So it might turn into somewhat convoluted construction method. Another problem here, potential problem, we would like our application to be configurable, and user preferences, we want to keep them on a server, and we fetch them from the server, but we do it unconditionally. We do it instantly at the construction time, and who knows where the server is located, and how much time, what is the delay, what is the latency, how long a user would wait. Now, let's say something goes wrong, and there is an error, and application needs to report this error. And before that, there is no need for user preferences, but the user would still have to wait until they're fetched. That's not right. And of course, sooner or later, almost everybody comes down to laziness. And normally here, what we start with. That's the basics. We have an attribute, and if it's not set yet, we see if it's defined or not defined, and we set it, depending on that. In order to implement that, of course, we make it a private attribute, and we manually create an accessor method for that. So far, so good. You see, the attribute is untyped. What if we want it to be a definite? Because we want to prevent some kind of errors related to that. We're in trouble because the compiler is going to complain about it. Well, there is no solution to this. We either need is required trait, or we need some kind of initializer. That I'll get back to later. And for now, okay, we're happy because we use just a simple constant. What if it's not that simple? We need to compute it somehow. The method turns out to something like that. I mean, it could be or defined with do statement or whatever, but the idea behind it is still the same. If it's not defined, compute it and don't forget to assign it back to the attribute. Well, we can win it down back to the original by extracting the computational part into a dedicated method, but then we have 2 methods. And the more attributes we have, the more methods we have as well. We have to write them manually each time. We get a boilerplate. Next case, the attribute could not only be a defined value. We may need it to hold some kind of a type object. For whatever reason, for example, we need to know what kind of plugin I'm going to use. And then with that plugin, we're going to initialize it, instantiate it, whatever. We need a trick to get around this because or defined doesn't work here. One way, for example, is like that, to specify a default value of nil, and we check for the default value. But what if nil is valid value as well? For whatever reason, it might be. We would need another trick here. Probably more complex, depends. But again, we get another boilerplate, and we get another kind of attribute to deal with. Next thing, okay, let's say that it's not a class, but a roles. I forgot to adjust the slide for that, but anyway, let's say that C is a role which is going to be consumed, in which case the class which is going to consume it, it has direct access to this private attribute, and that class would need to decide what to do depending on whether this attribute has been initialized or hasn't yet. I mean, like to find out whether it's been set already. Fine, if it's defined and defined, no problem. But since it holds an undefined object, we need to know the internal implementation of the role to deal with that. That's a bad idea. We need another kind of methods, which I once seen a definition of a predicate kind of method, has full, which hides the implementation detail and provides the user with information about that. But again, we get another kind of method, a third kind of method, and it's another boilerplate here. We have to write it for each attribute, which we may need to report back its status back to the user. So to sum it all up, we have different conditions, we have different requirements. For each requirement, for each condition, we have different solutions, we have different boilerplates, we have to manage them, we have to remember to write them, and so on, so on, so on. Worst of it is that sometimes it's about some tricks necessary, which is never a good thing. A trick usually means some kind of hack. Hack is, well, it's okay if you hide it inside. If you hide it in some code which is not visible outside, and you can easily manage it. But outside, you get some public API which is clear, readable, and apparent, preferably. That's where I came up with AttrX Mooish module. As the name suggests, it was at the time I was transitioning from Perl to Perl 6 back then, as you remember. The thing was called Perl 6. And I was very much used to Moo module. I used it a lot, and I got very much used to lazy attributes as they were implemented in Moo. And it was pretty much a disappointment when I found out that we don't have lazy attributes in Perl 6. I made even a proposal to introduce them. It wasn't accepted reasonably. It makes full sense. So that was my first published Perl 6 module, and I'm still terrified by some parts of the code of this module. But anyway, you know, we all evolve over the time. We get better, we learn something, and when we look back, many things we would have done differently. So I look back and I redo some things. Yet, if you look at the AttrX Mooish inside to learn something, better remember that those are just, you know, ideas. Do it differently. Basically, the most common use of the module is like this. You apply a trait, Mooish, to an attribute, and you use a couple of options to tell what kind of attribute is it going to be. Lazy is the most common one. I don't make it default because there are other ways to use the module. So you need to use lazy explicitly. Besides, it helps a lot with reading the code because you don't have to guess what is it all about. The module expects you to provide one method named after the attribute with build prefix, build dash prefix prepended. That's your construction method for this attribute, initializer, builder method, call it whatever. If you want a different method name, no problem, you can specify it, like here, get a num. The idea is that the same method can be used as public API. There are other ways to define those methods. It's going to be there. So when you have a class like this, and you create an instance of this class, your attribute is not initialized, your code initializer is not invoked until the attribute is read. Like the 2 lines below, the first instantiation got full initialized, but bar remains uninitialized, and vice versa. Also, look at the type definition. I mangle with build plan actually, and I allow definite types without initializers or is required trait. Helps a lot. Type checking is there, don't worry. I mean, you wouldn't be able to return an undefined value from your builder method. It wouldn't work. Remember, I was mentioning dependencies. Normally, in flat code, you would manage them with conditions. You're gonna check something. You're gonna have all those if-else trees, maybe nested in some cases, whatever. It's with AttrX Mooish, you just use your attributes. Everything else happens automatically because it's about laziness. For example, we get back to our application and we re-implement it in a different way. We still have user preferences. Okay, I changed the name to user config, but it's the same thing. We have isConsole attribute. We have two themes, colorful and monochrome, and we have actual color map, which we're gonna use when we output something. Say we ask for the color map attribute. What's going on then? You see, it checks out if it's a console we attach to, and depending on that, it chooses either colorful or monochrome. IsConsole is not initialized yet. So build isConsole method is called, and it gets its value from somewhere. If you initialize, if you set the attribute when you create an instance of the class, then build isConsole would not be invoked because the attribute is having a value already. Then, depending on the value in isConsole, you choose either colorful or monochrome attribute. And then you see I specified that I want to use getColorMap method as the builder method. And I want it to be an API method at the same time. What happens here? AttrX Mooish not just invoke the method, builder method, but it also supplies a couple of named attributes. You can find more in the documentation. But in our case, the one we need is the actual attribute name based in attribute named. And depending on that value, I strip off the first two, the sigil and twiggle. I get some final definition, and I request user config for a value for a specific color map, which I'm gonna use as a theme. At this point, user config wasn't loaded, and it's only then when user config get actually fetched from whatever source it is. It could be a server. We don't know, but it's only then when things happens. Otherwise, if you use it as an API method, we just supply color map name, and again we go to user config and we fetch it. But you can use the same method for different purposes. It just works. Sometimes it might be helpful. What's interesting here? You did nothing to manage the dependencies. Just nothing. It just works. All you need is a value, and you need to check out that value and make your decisions based on that. How everything else is handled, it's not your business. You don't worry about that. Remember I was saying, what if an error happens? In this case, color map is not requested. User config is never loaded. We don't waste time on all this if it's not necessary. We just print an error and die. That's it. About the same happens when we don't use other themes. For example, we attach to the console. To a console, we use colorful attribute. Monochrome stays uninitialized. We didn't waste our time on initializing it. Speaking about the configuration, again, as I said, we don't care where we get the configuration from. So let's say we want some kind of config manager which would take care of those matters. It would decide where the configuration is to be fetched from. For that matter, we use the undefined value in an attribute config handler. That value we're going to use to actually create an instance of configuration handler, which is going to actually do the job for us. What's interesting here? First of all, a new option predicate. If you specify this option, the AttrX Mooish module installs an additional has method for you. Another interesting thing is that it's not a public API thing how we handle the configuration, the handler itself. So the attribute is private. And every method which is related to this attribute, would it be initializer or the predicate method, they're both private. The builder is expected to be a private method. The predicate is installed as a private method. So that there is no way this API is gonna be published by accident. If it's private, it stays private. For user config, why we need the predicate? Let's say within the role, we don't want to accidentally initialize the handler. It's up to the consuming class to set it up properly. So what if it's not initialized? We just skip using this attribute and we create some kind of default handler and use it. But say this happened and later the handler has been initialized by the consuming class. So we need a new configuration at that point because handler has changed and the source of configuration is going to be different. For that, I use a clear option. It installs another clearing method, which resets a modified, I use this term modification, a modified attribute to its uninitialized state. So then next time after setting up a handler, you reset this user config, and when you refer to it, it gets a new value with the help of the handler. Configuration is updated and we can work further. Again, it simplifies things a lot. You just know that the value in that attribute is absolute, get rid of it. And another big feature of AttrX Mooish, I would change the order of the slide, filters and triggers, because that's the order in which they are getting involved. Hopefully names are safe defining. A filter is a method, a piece of code, a method, which takes a value before it makes it to the attribute itself, does something to it if necessary, or doesn't do, whatever, and whatever is returned from the filter is then used at the actual value. A trigger is a post condition. A filter is a precondition, and a trigger is a post condition. A trigger is invoked when the value is already assigned to the value to the attribute. And here we go. Sorry, this is pretty dense code. Hopefully that's okay, because I'm going to use it to show how dependencies are resolved with triggers and filters as well, and laziness when it's all put together. Again, same as for other options where method names are involved, you can define your own name for a method. So for filter, I use absolutizing method, which can also be used as a public API. What it does, it resolves paths, makes it absolute, and so it basically normalizes the path for later use. Good. So we are back on track to our configuration. We reconsider it a little bit. First of all, let's say I want to use some kind of templates. So how does it work? We create a configuration instance and we ask for index template. Nothing is initialized yet. Everything is empty. So the attribute templates gets built. To do so, sorry, the purpose of the attributes, because otherwise it's all unclear. base path is expected to be the top level directory where all application files are being kept, and template path is expected to be related to the base path, and this is where template files are stored. Good. So build templates needs template path. To do the template path is not built as well, so we get to build template path method, but it needs base path for that matter. We get to build base path where we finally get some value. At this point, we get the first filter involved. Because depending on how our application has been started, program may contain full paths, partial paths, related paths, whatever. We don't know. So we need to absolutize it. When filter is done, the value is passed, is stored into the attribute base path, and the control is given to the trigger. The trigger makes sure that path has changed. And to know this, it gets a named attribute named old value. So the first positional is the value which was stored into the attribute, and the named old value, because it's not always you need it, so you can omit it, this parameter. And if the path has been changed, trigger clears template path and templates attributes, because it knows that they're going to be changed. Most likely they're going to be changed. So at this point, this action is redundant, but it's not always like that. And also I shall note that this works only with the latest version of AttrX Mooish, because there was a restriction on where clear method can be invoked. It wasn't possible to call it while an attribute is being built yet. So now it's possible. We are done with base path. We get back to build template path. Again, we get a value for it. And again, we filter that value. It's stored back into template path. Its own trigger gets invoked, which also makes sure that path has been changed. And if it has, it also clears templates against the redundancy node. And now we are done. We have templates. And by looking at this, you can say that what we have here, it's a clear state machine where we did nothing to implement it. Again, things just happen. Whatever is the level of complication, it just happens. Good. What if we change the base path? I assume that the environment variable has some different value. At this point, the entry point changes. Now the first entry point is the filter method, and then it's the trigger. And currently we have template path and templates set. So path has changed, they both get reset to the initial value. Nothing else has been done here. If you're going to work with other attributes of the configuration, with other configuration values, until you request your templates, nothing happens. Time is not wasted until it's really necessary. I mean, I do repeat it once in a while, but it's really important part of it all. And so when we eventually need our templates, again, we build template paths because they both has been reset, filter, trigger, and the final value. And we are done. And you see, path has changed. It's now different sequence of events. But again, you did nothing to change it. It's been done for you. All you need is just define different states and your actions in those states. I think it's great. I use it everywhere. The only thing is that I had some application for triggers and filters a while ago, but since then, I somehow shifted towards different approaches. I now Instead of using write table attributes, I'm more inclined to use setting methods. But otherwise, little changes here, because you can as well assign to a private attribute, and it's going to be working. And the last feature, it's not the most important, but it's fun to have, aliasing. If you want to use different names for your attribute, you just can alias it. You can use one alias, several aliases, whatever. What happens here is accessor method has different, gets different name. I mean, 2 additional accessor methods are installed. Predicates and clears get different name. The builder remains the same. You have always used the original name with the builder. And actually, the option itself has aliases as well, depending on the semantics you want from it, whether it's about using the attribute under different naming, or it's only about initializing it, or single or multiple, whatever. And that's how it works. I mean, you can see you initialize it under B, predicate, use predicate under full, read as A, then clear B, then read from full, and it all works. Just convenience. Now, of course, it's not all about the bright side only, apparently. There are things to consider. First of all, the module is very much built into Raku internals. It uses some very specific implementation details like build plan. Normally, it's not a problem because those parts it relies upon, they're very hard to be changed. I mean, changing them would require a lot of efforts and might break a lot of things, but still, there is a chance, there is a possibility. I follow the development, of course. I try to adapt the module when necessary, but so far, the only case when it was necessary, it's when internal numbering of build plan events has been changed. But then again, I done it in a way that the module just checks for compiler version, and it's still compatible with old ones, though I haven't tested it in a while. Need to check it out. Still, it's implementation specific. Okay, Rakuda is currently the only compiler, but even if we get another compiler sometime in the future, I think it would be possible to re-implement the module to support both compilers, because I want it this way. Unfortunately, there is no alternative here because, for example, making definite types possible requires mangling with the build plan. There is no workaround for that. Concurrency or thread safety. Let's get back to the basics. When we create an instance of a class and we initialize attributes of that class, that action happens only once and exactly once in a single thread. There is no way it could happen in multiple threads until you somehow make efforts to do it that way. But okay, that's out of the scope. It's different for lazy attributes, of course. You have an instance, and then you can accidentally read from an attribute in 2 different threads, 3 different threads, whatever. So to make this behavior be no different from the standard one, I guarantee that builder methods they're concurrent safe, thread safe. A builder would never be invoked twice for initialized uninitialized attribute unless you clear it somewhere in between. So if accidentally 2 builders are invoked simultaneously, 3 builders, whatever, only one of them would actually take place. 2 other threads would just get their value out of the attribute. Clearers, it's a side effect of internal implementation, but clearers are mutually safe as well, though they're not mutually safe with builders. You cannot mix them up. Here is the reason for that. The only warranties I make is the warranties you have for non-modified attributes. In other words, write operations on an attribute, they are not thread safe. If you write to an attribute, make sure you don't create a race condition. From this point of view, resetting an attribute, it's also a write operation because you change a value in it. It might eventually end up with the same value, but in between, you erase that value. Can think of it a little bit like about assigning nil to a container. It's going to be reset to its default value. Am I compatible with other traits? Barely. I don't think so. Except for such core attributes as RW is required, is default. Otherwise, if another trait modifies mangles with the container bound to the attribute or otherwise tries to mangle with attribute behaviors, there are likely to be conflicts. So you can try, you can test, but be careful. I give no promises here. This is a little bit funny thing. It was a surprise to myself, though it's fully logical. When many of you probably know this situation where you have a scalar container and you store an array or a list into that container, and you try to loop over it, and you get exactly one value, the array itself. That's because a loop considers scalar containers, non-iterable containers, as a single value. Proxy container is also a non-iterable container. So it's also considered as a single value. I think it's a bug. I probably should take care of it, but so far that's where we are. What happens here, and how does it affect the code? Here is the thing. A lazy array attribute, we initialize it with, okay, 2 values, whatever. And then we try to loop over it. Keep in mind that here I use it as a private attribute. I refer to it directly to the attribute. I bypass the accessor method. That's important. First of all, I print .var value, which is actually the container bound to the attribute. As you can see, it's a proxy. That's how the module works. To implement its features, it binds an attribute to the proxy. So we try to loop over that attribute. At this point, it gets initialized. And what we get out of it, out of the loop, we get just single value, as I promised you, an array. We do it again, and this time it works as expected. Because what happens in between? When a lazy attribute is read and built, the module steps aside by unbinding the attribute from the proxy and reminding it to the actual container which is supposed to be there. From this point on, you use attribute as a normal one. Laziness and is not involved anymore. So we clear it just to see what happens. And when we look over it, we get an error again. That's because the attribute, after clearing, the attribute gets rebound to a proxy. That's its uninitialized state. How do we get around this? There are three ways. First, we can explicitly decontainerize the value. And second, we can explicitly coerce it into a list. This works. This is pretty much common workaround for scalar containers. Or another workaround is actually to use the accessor method, because in this case, the actual initialization of the attribute takes place inside the accessor method, and what gets returned is the actual array. So far, so good. I'm sorry, I'm drinking a lot because I just out of COVID, and one of the side effects is dry mouth. Performance. As I told you, the implementation is done by using a proxy. Hopefully, many of you knows that proxies are known to be rather slow, because it's not just a container where you store a value. You have to get through a number of code calls before the value actually gets where it's supposed to get to. When you create a proxy, you use two code objects of your own, one for reading and one for writing, fetch and store. So the initial initialization is pretty much expensive, apparently. But the thing is that it happens exactly once. And when it's done, as I told you, the proxy goes away. Ooh, and we are free. From that moment on, your attribute is just an attribute with all the implications, all the specifics of a normal container. Don't worry about it. I mean, the cost of initialization, most of the time, it's neglectable. Just keep in mind that most of the time it's going to be spending within your initialization, within your build method, especially if it takes a long time. Different case is when you use filters and triggers, because in this case, there is no way to unbind the proxy. The module has to control the flow of data, and the only way to do it is to use a proxy. It has to remain bound to the attribute. And of course, it costs you some CPU cycles, a lot of. That's why, as you remember, the example I used for triggers and filters, it's about a configuration class. Because normally, nobody uses a configuration value in a tight loop. It's pretty much a bad idea, because the value can change in time. You better prefetch it somehow and use that prefetch value. So configuration is not the kind of class where you would suffer from performance losses. So when you use filters and triggers, be warned, they're useful, but this use comes at a price. A special note, again, is when you pass them as attributes somewhere. Because filtering and triggering attributes used as arguments, for example, you use them with a say. A say could read from them up to 4 or 5 times in a row. That's because there are multiple dispatcher involved. There are stringifying methods involved, gist in particular, and so on, so on, so on, so on. Each read its time. And something non-technical, more like logical. Try to avoid unexpected behaviors. Laziness could be surprising. So think careful. For example, a few days ago, I have done a little project, it turned out to be more than a little, but anyway, of modifying libxml module. And the module used global configuration. And it was implemented by a way that when you refer to it as a type object, it uses values kept in local variables. So when you do just config.threshold, you actually get a value from a variable, local variable. The modifications I was doing, they required localized versions of configuration. So I introduced attributes, and I decided that it's going to be a good thing to have them as lazy ones, because if you don't need some value, well, then you don't need it. Good. When it comes to a test where I use some global value, I make sure that the value is as I expected. Then I create a localized copy of the configuration, and it's not used until some point later in some document instance. In the meanwhile, some other test changes the global value, and the test fails. And it fails because the lazy attribute got its value after the global value has been changed. I didn't expect that. I mean, intuitively, when I created a new instance, which I expect to reflect the original global configuration, I expect all the values to be inherited from over there. So I had to rip off all the laziness altogether. So actually, I changed the scheme at all. In general, I switched to using a singleton, but that's a different story. So that's another thing to remember about. And I think I'm done. Thank you very much, everybody. It was my great pleasure. And as all you know, all the war in Ukraine, I'm trying to help some military squad which is fighting near this Mykolaiv city currently. So if you can help me with donations for that squad, I would pretty much appreciate it. This QR code is for my PayPal account. I'm sorry to put it here, but really it's way too important for me. Just to mention it, as long as I was having this talk, I got some news notifications on my phone, and they were about some more rockets landing down in residential area in the city of Mykolaiv. So Ukraine is being destroyed currently, and I'm trying to do whatever I can to prevent it. Thank you very much, everybody. And if you have any questions, you are very welcome. Telegram, IRC. I don't think we have time for leave questions over here. I'm done. Thank you.